The table below shows corresponding values of x and y for y equals the log equation. Okay, the values of y are given to two decimal places as appropriate. So we're given some values of x and they've already computed the values of y using this equation up here. Now, using the trapezium rule with all the values of y in the given table, obtain an estimate for this integral, giving your answer to one decimal place. Okay, so essentially guys, we just got to use the trapezium rule. So whatever you guys do, don't attempt to integrate this problem. If you do that, we wouldn't actually get a mark. So yeah, let's avoid that. Now, to use the trapezium rule, the formula is a bit like this. We have a trapezium rule t, and we say that it's approximately equal to the change in x, so they use h in their definition, over 2, and then we're going to multiply all of this by a big bracket, and in this bracket we're going to have the first term of y plus the last term of y, so we call this first plus last, and then it's going to be plus 2 times the sum of the middle terms, so middle terms. Okay, this is just how I personally write it, and I prefer to write in words at times, especially when the formula is a bit confusing. So essentially guys, we're just going to pop in all these values here. So we say that, okay, by the trapezium rule, we can see that the change in x is pretty much the gap between each x value, and as we can see, it's going up in more or less 3s every time. So we say that the change in x is just 3, and then it's over 2 times the first term, which is 2 for y, plus the last y term is 4.81, plus 2 times everything in between. And by between, we're talking about these values here, yeah? So it's going to be 3.32 plus 4 plus 4.46. Okay, and then we just put that all in the calculator, and once you put that all in, they want us to round your answer to one decimal place. Now before you do that guys, it's always a good idea to actually write the full answer first, yeah? So according to the full answer, we should get 45.555, and to one decimal place is 45.6. Yeah, and that's A done. Now it says, using your answer to part A and making your method clear, estimate the following two integrals. Okay, so for the next two integrals, the trick behind this is that we need to kind of rewrite the log bit into this upper part A log expression. Okay, so let's have a go at that, yeah? Now just focusing on the log 2 4x squared bit, so I'm going to write that here. So part BI, we've got log 2 4x squared, and now using some kind of tricks, like in order to get this 4x squared into some kind of 2x expression, you might notice that these two are actually squares of 2x. So what I'm trying to say here is that this is pretty much identical to log 2, and if you put a big bracket, we're going to have essentially 2x all squared. Okay, that's exactly what it is. And now one of the interesting properties of log is that if you've got a power inside the log, this power goes in front of the log term. So this is actually now just 2 times log 2, and then you're just left with 2x. So yeah, so actually all of that just becomes 2 log 2, 2x. So if we put this all back into the integral and just take this 2 and this 5 behind integral, so guys, when you've got constants like 2 and 5, they have no effect in integral, so you can put it behind. You're essentially going to have now 2 over 5 and the integral of, well, the rest of this, 2 to 14 of log 2 2x dx. And well, we know what this integral is. We just evaluated in part A. We actually got 45.6. So that means the answer is going to be 2/5 of, but it's always better to use a full answer, yeah? 45.555, and then put this in your calculator. It should be estimated to about 18.2. Okay? Now, for the second bit, it's kind of the same idea. So let's just copy out log 2 over x for a second, yeah? So for part 2, we're going to have log 2 over x. And once again, the main idea is to always kind of invert the 2x into this. So we need to somehow rewrite 2 over x as 2x in some capacity. And unfortunately, there is no clear way, but the best way to do it is to actually multiply up and down by 2. Because if you multiply up and down by the same value, it's like multiplying by 1, so nothing necessarily changes. So let's just do that for a second, yeah? So multiplying up and down by 2, we're going to have essentially 4 over 2x, which is identical, they're the same fraction, But now we're going to use another feature of the logs, which is if you divide some terms inside a log, is the same as subtracting log terms. So what this means is that we now have log 2 of the 4 term minus log 2 of the 2x term. And now log 24 is just a value you can just put in your calculator, or you can just guess it, or just know it. The actual value of this one is in fact 2. And then this log 2 2x, well, that's exactly the form we're looking for. This is the form we want from the previous questions. Now all we can do, guys, is just put this into the integral sign. So it's going to look something like this. We now have the integral from 2 to 14 of 2, and the good thing is when you plus or minus, you can separate the integral terms. So it'll be the integral of 2 take away the integral of this. So integral 2 dx minus the integral of 2 to 14 of log 2 2x dx. Okay, so that's good so far. Now integrating 2, well, that's not too bad. It's just essentially, well, if you integrate any constant, you just get an x, so it'll just be 2x, and then you just apply the limits from 2 to 14. And all this means is that you first plug in, replace x of 14, so you're going to get 2 times 14, which is 28, minus, and then replace x with 2. 2 times 2 is 4. So this value is just 28 take away 4, which is 24. And well, for the second bit, we know what that is. That's from part A again, which is 45.555. So we just put that in 2. So 45.555. And then therefore, we just say, okay, subtracting these results, 24 minus this value, and again, rounded to 1 decimal place, you're going to get a result of minus 21.6. And that's your one done. Okay, question 2. One of the terms in the binomial expansion of 3 plus ax all to the power 6, where a is a constant, is 540x to the power 4. Okay, find the possible values of a. Now, for this question, and interestingly for all the binomial expansion questions, the best thing you always want to do is always try and expand this as much as you can until you get to x to the power 4. Because the main idea is to pretty much equate this to some term over here. So the way I'll do this, guys, is this. So I would firstly write down the binomial expansion formula here. And the way I personally do it is I always start with a summation sign because it just feels natural. And because we know we're going up to the power 6, we always begin at n equals 0 all the way to the power 6. Now this is just a case of order, yeah? The first term should always be this symbol, which is 6 choose n, where n is pretty much your number of terms. The next part would be the 3, yeah? So it'd be 3 to the power of 6 minus n, yeah? So you're always kind of going back here. And finally, you got the ax, which is going to be ax to the power of n, and that's your current position. So let's go ahead and expand for a second, guys, yeah, and try and do it in the easy way possible. So we start from n equals 0. When you plug in 0, you're going to get 6 choose 0, and then 3 to the power of 6 minus 0, which is just 6, and then ax to the power 0. Okay, we can just leave in this form now. And then we do the next set. Replace n with 1, we get 6 choose 1, 3 to the power of 6 take away 1, which is 5, and then we got ax to the power of 1. And you probably realize that if we keep on doing this, you know, we're going to do this for a bit, we'll eventually get down to the fourth one, right? X to the power 4. So let's just put dots there until we get to 6 choose 4. We're now going to have 3 to the power of, well, if we think about when n is 4, 6 take away 4 is 2. And we got ax to the power of 4. Okay, and again, this will keep on going until you get to the final term, which is 6 choose 6, 3 to the power of, well, 6 take away 6 is 0, and then ax to the power of 6. Okay, so just ignore the other terms. Now, because they want us to match, what is it, some term which is x to the power 4, we're actually looking at this term right here. And if you were to put this in your calculator, 6 choose 4 times 3 squared, you'll get a result of something like this. You'll get 135, and then you can just expand this little bracket. You get a to the power 4, x to the power 4. Okay, and now just looking at this carefully, you got 540 x to the power 4 and 135 a to the power 4 x to the power 4. So just pretty much equate them, yeah? So they're saying the coefficient of this x to the fourth is just 135a to the fourth. So guys, what I'm trying to say here is that the 135a to the fourth, it must be equal to 540. So 540. And that's it. And then you just rearrange this and solve. So what I'll do is divide 135 across. So you get a to the 4 equals 4. Now this is the part where you gotta be careful, yeah? Because unfortunately you can't fall through and get a proper answer. Because I think, well, they don't explicitly tell you to find it in exact form. You could just find a fourth root, but I'll do it step. I'll find the square root first, guys, because we know if we square root both sides, you get a to the squared equals 2. And if we square root this again, you're going to get a equals plus minus root 2. And that's your two solutions of a, plus minus root 2. So now looking at b, it says hence, so this means continue from the previous. Find the term independent of x in this given expansion. Now they use the term, the phrase independent of x. What that means is that if you had to expand this fully, all you care about is the terms that have no x attached to it, yeah? And you can see that there's not going to be many terms because practically almost everything, except the first term, because ax to the 0 is just a constant, is nothing, has an x term. So all of these have an x term except the first. But another thing to note here, guys, is that we have x to the 6. And the only way to pretty much cancel this term is to times it by itself, which is another x to the 6. So let's just write this down for a second, yeah? So for part B, we got 1 over 81 plus 1 over x to the 6. And they want us to multiply against our binomial expansion, right? So instead of this term here, we're going to replace all of this with what we found over here. This kind of chain, yeah? And I'm going to quickly just evaluate this, guys. When you got the first term, 6 choose 0 times 3 to the 6, that's just going to give us, all of that will just give us 729, plus the second term in the series would be this one here, 6 choose 1, 3 to the 5, and ax. Evaluating all of this, guys, should give us 1458 ax. And well, if we keep on doing this, yeah, plus dot dot dot, we're eventually going to get to the final term, 6 choose 6. And if you put all of this in, well, this gives you 1, this gives you 1, so 1 times 1 is 1. Ax to the power 6 is just a6x to the 6. Okay, now let's see what's next here. So using the normal expansion method, we'll have to multiply term by term. So you basically do 1 over 81 times this, and 1 over 81 times the next one, and so on. But we're not going to do that, guys. What we're going to do instead is multiply 1 over 81 with 729 only, because if we multiply this with every other term, we're going to get an x. And we're going to multiply 1 over x to the 6 with the final term. Again, this x to the 6 will cancel with this x to the 6. And if you do that, guys, you're pretty much going to get an answer of, well, 1 over 81 times 729 will give us just 9, plus, and just ignoring the rest of the terms, if we go straight to the last term, 1 over x to the 6 times this would just give us a to the 6, because x is cancelled out. And that's it, guys. And then we just say, okay, all we care about is 9 plus a to the 6. And we know what a was, yeah? We said earlier that a was plus minus root 2. Let's just choose root 2 for a second, yeah? And if you plug in root 2 here, you're going to basically get 9 plus root 2 to the power 6. All of this is literally going to give us, in your calculator, a 17. And that's it, guys. That's your question done.
Okay, 3. So use the factor theorem to show that 2x plus 3 is a factor of this function above. Okay, so according to the factor theorem, guys, it literally tells us that if we let this linear term equal 0, so in other words, 2x plus 3 and set it to 0, and find a solution of x, well, in this case, x would be, well, minus 3 over 2. And if we substitute this value x into this function, then we should get no remainders. So in other words, guys, let's plug in f minus 3 over 2 into the equation. All we literally do is replace all the x values here, guys, with minus 3 over 2. And if you do for every single case, you should come up with a result in your calculator that should be 0, yeah? So just double checking. And when you write this, put this on the calculator, and again, your answer should be 0. And therefore, we say 2x plus 3 is a factor of fx. That's it. There's literally nothing to it. We know it's going to be a factor because it actually tells us to show that it is indeed a factor. So honestly, guys, don't bother working out. You're going to get 0 for sure. Now looking at B, it says, hence, using algebra, write fx as a product of three linear factors, okay, given that we already have one factor. So essentially, guys, we have a cubic equations and we need to break it down to three different brackets, yeah? Now, the easy way to do this, yeah, because we know 2x plus 3 is a factor, we could just use long division. So let's try out here, yeah? So we've got part B, and we're now going to do 2x plus 3, and we're going to do a long division on, let's copy out the top equation, 6x cubed, the 6x cubed plus 17x squared plus 4x minus 12. Okay, so we're going to do this step by step here so we can understand every single part. Now, the way long division works, guys, and it's just like normal division, you look at the very first term and you ask yourself, how much does 2x go into 2x cubed? Well, we just do a division. We just say, all right, 6x cubed over 2x. If we're going to divide this step by step, 6 over 2 is 3, and x cubed over x is x squared. So you're going to put this result up here, okay, right above the x squared column. And a little note, guys, always line up your answers in terms of powers, yeah? So x squared here, x, and constant here. Now, step 2. What you can do next is use your result and times against this bracket here. So 3x squared times this linear part. When you do that, you should get an identical result of, again, 6x cubed, but this time plus 9x squared, okay? And now all we do is subtract these two, yeah? So subtract these two values. And when you do that, well, 6x cubed take away 6x cubed is nothing. 17 take away 9, and they both will x cubed. You're going to get an 8x cubed. And then that's pretty much the main idea. And next, you would have to drop 4x down. So you're going to get plus 4x. And then once again, guys, just rinse and repeat. So look at 2x and see how many times that goes into ax squared. So just write on the side. Ax squared over 2x. Well, that should give us a 4x. So we're going to write that result up here. And again, we're going to now use that 4x and multiply against that linear term, basically repeating everything. 4x times that will give us another identical result of ax squared, and this time plus 12x. And yeah, so we just keep doing this. And then subtracting these two, 4 take away 12 is going to be minus 8x. Again, these x squared terms always cancel out. And now we just drop minus 12. So it'd be minus 8x minus 12. And lastly, we do the same thing. How many times does 2x go into minus 8x? Well, we just do minus 8x divided by 2x. Simplifying the result, you get minus 4. Okay, so that minus 4 again goes right to the top. And just to wrap it up, we're going to do that. We're going to use that minus 4 and multiply that linear term to get another result of minus 8x minus 12. And the cool thing about this, guys, is that because you know that they are all factors, your remainder is always going to end up becoming a 0. If you don't get a 0, then it's probably best to check what went wrong. So we can now say that fx now equals the linear term, 2x plus 3, times the quadratic term, which was 3x squared plus 4x minus 4. Okay, so factorizing the second part now, and we'll be done here. We should get a result something like this, yeah? So it should be 2x plus 3, and then the first bracket should have a 3x, and the second bracket should have an x, yeah? Why? Because we know that 3x times x gives us 3x squared. Now we just need two numbers that multiply to get a 4, yeah? To get a minus 4. And the only two values I can think of, well, two pairs would be 1 times 4 or 2 times 2. Out of these two pairs, we need to multiply one of these digits, either 1 or 4, by 3 to give us some difference of 4. Well, that's not actually possible. If we multiply one of these 2's by 3, let's say, well, this one by 3, we're going to realize that 2 times 3 is 6, and 6 and 2 has a difference of 4. So that means you can say, all right, 3 times 2 is 6, and put another 2 here, we can get 4. How? If we get 3x times plus 2x, this gives us a 6x, minus 2x, and we're done. This gives us our final result. We now need to solve theta, which is given in radian modes, the following equation, yeah? So, in fact, you know what, just taking a moment to look at this, we can see that this equation, which is now in terms of tan theta, is actually the same as the x equation above, isn't it? The only difference now is that x has been replaced with tan theta. So x equals tan theta here. And now because it's equal to 0, they actually want us to solve this, yeah? So the best way we can do this, guys, is to actually use our result from part B, the three linear factors. Instead of solving for x, we're going to solve for tan theta. So let's start with that, yeah? Let's go ahead and use our answers from part B. So just looking at this one for a second, this is if we just let this equation equal 0 now, and this is going to be part C, yeah? We pretty much can get three solutions here. If you look at the first one, we have 2x plus 3 equals 0. We found that earlier that x here is pretty much minus 3 over 2. For the second part, x would be, well, you can add 2 across and divide 3, so it'd be equals plus 2 over 3, or x here could equal negative 2. That means if I'm going to scroll down for a bit, and one more bit down, this means that tan theta is actually equivalent to minus 3 over 2, or tan theta is equal to plus 2 over 3, or even equal to minus 2. So you actually got three different results now. Now, to get the value of theta, we just have to tan inverse, yeah? So in your calculator, it looks a bit like that. It's just this little button here. And to get it, you go press Shift Tan. So inversing each of these results, guys, you should get values of minus 0.983 for the first one. Second one, you should get 0.588, or also minus 1.107. Okay, so at this stage now, we need to see whether these values fit the range, yeah? Now, if you remember in the question, it said that theta, the values of theta only allowed between pi over 2 and pi. Now, if you don't like how this looks, what this actually means, and if you want, you can replace pi with 3.14. Pi over 2 is actually 1.57, and pi, of course, is 3.14. So they want answers between this range. And as you can see, we ain't got a single one. Now, how do we get them? Well, two ways. We could use the cast or quadrant method, but that's a bit long. The second method is to also just realize that for tan graphs, and that's just by sketching, yeah? To use a tan graph, we should realize that every single 180 degrees, it just repeats itself, like forever. So what it's trying to say here is that if you had a result on this value here, that means what if you add an extra 180 degrees, you get another similar result here, and so on. So essentially, to get other results, we can keep adding 180 degrees to our actual result. But because we're working in radians, we can't use 180 degrees. We've got to use pi, because in radians, 180 is the same as pi. So that means, guys, for every single answer here, to get additional answers, keep adding pi. So for the first one, if we add pi here, we would actually get 2.16 in our calculator. If you add pi for this one, you would actually get 3.73, which is outside the range. So far, 1 is good. And lastly, if you add pi over here, you'll get another answer of 2.03. And yeah, guys, I think that's really it. If you want additional answers, again, you can add an extra pi or an extra pi and so on. Or if you want to go backwards, if you want to go back through the tan, you can subtract pi. But for the purpose of this question, they just want answers between these values. So our final answers are 2.16 and 2.03. Now, figure 1 shows a sketch of the curve with equation y equals 2x squared plus 7. Okay, so this is just part of the curve. And it says that the finite region R, so the shaded region, is bounded by the curve that we see, the y-axis up here, and also a line y equals 17. They want us to find the exact area of R. So the easiest way to compute the area of R is to actually divide into two shapes here. And the first thing is to realize that this can be formed as a nice rectangle, yeah, going downwards. And one other property is the fact that if we had to integrate this expression, yeah, we could actually find the area under the curve. And that's what happens when you integrate and set limits. You actually end up finding the area under the curve right up until the x-axis. So this is the area we would be finding, okay? Now, to find out how far to integrate, well, we need a limit. We're only going to integrate up until this line here. But we don't know what this value of this line is. The only thing we do know is that it hits at y coordinate of 17. So what we could do, we could use this equation here, plug in y equals 17 and find x. So let's do that for a second. Let's try and find the x coordinate here, yeah? So we say, okay, when y equals 17, we now have 17 equals 2x squared plus 7. So just subtracting 7, we got 10 equals 2x squared. And then we could just divide by 2 to get 5. And then square root to get x equals root 5. it's only going to be a positive root 5 because it's going to be on the right hand side of the graph. And it tells us that x is greater than or equals 0. So now we know that this is root 5. We can now realize that this is just a nice rectangle with an area of, well, the base here is root 5, the difference is root 5, and the height is 17. So we can say that the area of the rectangle is just 17 times root 5, which is actually just 17 root 5. So that's the whole area, yeah? However, to get the region now, we need to subtract this rectangle from the area under this curve, yeah? So let's do that, yeah? To do that, we can say, alright, therefore the region itself is the area of the shape, which is 17 root 5. And we're going to minus it against the integral formula, which is the integral from 0 to root 5, because that's how far we're going, of this curve. So we're going to use the curve as a baseline, yeah? And the curve equation was 2x squared plus 7 and then dx. And yeah, guys, if you could just evaluate this, then you're done. So evaluating this carefully, so let's have a look. Now, to integrate this one, the rule is that you always increase the power by 1, then divide it, yeah? So I'm just going to put a big bracket so we don't mess this up, yeah? So this would be a 2x cubed over 3. If it's just a constant, add an x, so it'd be 7x. And because you've got limits, which are 0 and root 5, you just put them up here, root 5 and 0. Now, to use limits, guys, all you do is just plug in the upper limit first, so replace all the x's with root 5, then subtract it with x when x is 0. So it looks something like this. We're now going to have 17 root 5 minus, so first we use the root 5, we're going to have 2 bracket root 5 cubed over 3 plus 7 root 5, okay? And then we're now going to minus it when x is 0. Well, when x is 0, they're both 0. So in fact, we don't even need to write that. We can just delete all this. Now, at this stage, we now need to simplify this carefully. Okay, 17 root 5 minus, now going to have 2. Well, root 5 cubed is actually 5 root 5. 5 root 5 times 2 is going to be 10 root 5. So this would be minus 10 root 5 over 3. As we're expanding the bracket, this becomes a negative 7 root 5. And now this is all easy. Now we're just collecting like terms, yeah, in terms of root 5. So if we just factorize root 5 for a second, yeah, we basically got root 5 outside, and now we got 17 minus 10 over 3 minus 7. If you put all of this in your calculator, guys, you'll get 20 over 3. That means our result is now 20 over 3 root 5. And yeah, that's the end of this question. Alright, number 5. So in this question, you must show all stages of your working. Solutions relying on calculator technology are not acceptable. Okay, so what it's trying to say here, guys, is that you can't just use some kind of equation and just get the answer without showing proof, okay? So I'm going to show you guys the proof of how to do this question, yeah? So let's begin. Now it says that a colony of bees is being studied. The number of bees in the colony at the start of the study was 30,000, okay? 3 is after the start of the study. The number of bees in the colony is 34,000. Okay, so it's increased by 4,000. A model predicts that the number of bees in the colony will increase by p% each year, so that the number of bees in a colony at the end of each year of study forms a geometric sequence. Alright guys, so essentially they want us to pretty much form a geometric sequence, but an easy way to do this, guys, is to use a particular formula which I like to use. I call it the OVNV formula. That is, that you have some original value, increases by some rate, let's say 1 plus some rate p, for some number of years, and it should give us a new value. Well, in this case, we know that the original value is 30,000, and we know that, well, we don't know what the rate is, that's what we're trying to find, but we know this lasted for 3 years, and then we ended up with 34,000. And yeah, all you can do here, guys, is literally just rearrange and find the value of p. So to do that, I'll divide 30,000 across, so I'll be left with 1 plus p to the power 3. Well, 34,000 over 30,000, that just simplifies to 17 over 15. And then you could find the cube root of this, and then subtract 1. So therefore, you can say p equals the cube root of 17 over 15, and then minus 1, and you actually end up with a p result of roughly 0.0426. And because they want p as a percentage, well, you can say therefore p is actually 4.26%. And that's it, that's literally A done. As for the next part, it says according to the model, at the end of n years, so now instead of 3 years, we've got capital N years, the number of bees in the colony exceeds 75,000. Okay, find, showing all steps in your working, the smallest integer value of n. Okay, no problem. So an easy way to do this is literally use the same approach. Now we can say that the original value is still 30,000. 1 plus p is literally 1.0426. We don't know how many years because they said capital N, and it's supposed to exceed 75,000. But we're just going to use the equal sign for now, yeah? So no big deal. Now all you want to do here, guys, is the same thing, except now we're trying to find n. So to do this, first divide 30,000 across. You're going to have 1.0426 to the power of n equals all of this over 30,000. That's just 75 over 30 basically. And now I would just take logs here, guys, yeah? Because to find n, you need to take logs on both sides. So take logs, you have something like log 1.0426 to the power n equals log 75 over 30. Now, a very useful property of the logs is that when you got power inside the expression, it goes in front of the log. So it looks a bit like this. So it becomes n times log, and then you got 1.0426 equals log 75 over 30. And now all you do is literally drop that thing across, or divide the log term to the right. You're going to have n equals log 75 over 30 over the log 1.0426. And then just drop that in the calculator and you should get an end result of 21.96. And they said something about the fact that we need to find the smallest integer value of n. And well, because we know that it exceeds 75,000, so essentially we could say that n, therefore, so I should correct this, therefore n exceeds 21.96. This means that n has to be 22 because that's the smallest possible integer after that number. And that's it, guys, we're done. The circle C has equation x squared plus y squared plus 6x minus 4y minus 14 equals 0. Now they want us to find the coordinates of the center of the circle and its exact radius. Now guys, yeah, every time you got a circle equation, always think of this equation, yeah? The general form of a circle is always x minus a all squared plus y minus b all squared equals the radius squared, where the coordinates a and b are your center and r is your radius. Okay, so essentially, guys, to get this equation into this form, we need to complete the square. Firstly for the x bits, and then the y bits, and then rearrange it to make it all equal some constant. So let's do it, yeah? I'm going to go ahead and pull this equation down a bit. So looking at x squared plus y squared plus all of that, I'm going to deal with x squared plus 6x. So to complete the square, the key objective is to always half the coefficient of x and you get 3. So you should get x plus 3 wrapped up in a square. And then for the next bit, for the y bit, you got 4, so half of 4 is 2. So you got y minus 2 wrapped in a square. And now, before we get to the minus 14 bit, we're now going to subtract what we just halved, yeah? So we're going to subtract 3 squared and subtract 2 squared. It doesn't matter if it's plus or minus because you still get the same result. And then we copy the rest, which is minus 14 equals 0. And yeah, it looks like we're pretty much done here, guys. Now all you do is just move this to the other side. So therefore, x plus 3 squared plus y minus 2 squared, guys, has to equal 27. So looking at the original equation, 27 equals r squared, meaning the radius r is root 27. And the center of the circle, again, has to be in minus a minus b form. That means a is going to be minus 3. So the center would be minus 3 and positive 2. And that's it, guys. That's your part A done. Okay, for part B, it says that the line with equation y equals k, where k is a constant, is a tangent to C. So what this means is that you have a circle, and then a tangent is just a straight line that cuts at exactly one point, yeah? Now, because we know it's that y equals a constant, we know it's going to be a horizontal line, because k could be any positive number, right, or negative number. So these are the two possible places it could hit, either down here or up here, yeah? So this could be y equals k, or this could be y equals k. So they want us to find the possible values of k. Now to find the possible values of k, because the line is intersecting with the circle, this means we can solve this simultaneously. In other words, we can replace the y value of k and plug it into our circle equation. So to make it easy, I'm going to go ahead and use the very first equation at the top because everything's already expanded out, right? So replacing all this y squared and y with k squared and k, so let's just put it down. We're now going to have, and we can call this part b, x squared plus k squared, and I have to keep looking up, plus 6x minus 4k minus 14 equals 0. Now this question is actually a discriminant question in disguise because the only way you can compute k is if you use the discriminant of x. Okay, so the discriminant x tells us that we need to rewrite this in quadratic form. Well, we got x squared plus 6x, and now we have a massive constant of k squared minus 4k minus 14, and that's going to equal 0. So using the definition of the discriminant, the formula is b squared minus 4ac equals to 0, right? Where b is going to be the 6, the coefficient of x, a is the coefficient of x squared, so 1, and c is basically all of these lot. So substituting that back in, guys, you're going to have 6 squared, which is 36, minus 4 times 1 is 4, times k squared minus 4k minus 14 equals 0. So now we're going to go ahead and expand this bracket. So we should now have 36 minus 4k squared plus 16k plus 56 equals 0. And then tidying this up, we're going to now have, and put this in quadratic order, we're going to have minus 4k squared plus 16k plus 92 equals 0. So now guys, if you just want to find k here, this is just your typical quadratic equation. I will just use the quadratic formula. So we can say, okay, let k equal minus b plus minus the square root of b squared minus 4ac all over 2a. In this case, our a is minus 4, which is the coefficient of k squared, b is plus 16, and c is 92. And when you put all of this in, you should get 2 plus 3 root 3 or 2 minus 3 root 3. And that's it, guys. And finally, it says that the line with equation y equals p, where p is a negative constant, is a chord of c. And given that the length of this chord is 4 units, find the value of p. Okay, so I think it's better we have like a visual understanding of this, yeah? So what I'll do is try and graph this visually. So let's try and plot this. So suppose you go on x-axis all the way across, yeah? And you're going to have a circle, which I believe dips a bit below the line. We know the center is above it because we know it's minus 3, 2. So it's minus 3 on the x-axis, but it's above on the y-axis. So let's just say, I don't know, probably somewhere here, right? So this would be a 2. So we know the chord is going to be on the negative axis. So somewhere like here. And we know it cuts off at p because it's y equals p. Now the interesting thing about this is that if we had to just stretch this line down, we could essentially just find the length of this line. Why? Because we know that the actual length of the chord is 4, meaning half the length is 2. And the cool thing is you can actually form a right angle triangle from this. Now suppose we decide to connect this line to this line. This is just the radius, guys, and we know that the radius from earlier was root 27. So the only thing we need to calculate is this difference here, which we can call it v. Now, if you can work out v is, v would literally be the difference between 2 and p. So p is going to be 2 minus v. So, and that's it, guys. Using Pythagoras, work out v, you've essentially got p. We're going to have v squared plus 2 squared equals the square root of 27 squared. And then making v the subject, guys, it's just going to be v squared equals, well, root 27 squared is just a whole 27, minus 2 squared is 4, so that's actually 23, and the square root of 23, well, just call it root 23. And that's it. So the actual length of this one is root 23. That means p is root 23 less than 2. So yeah, so therefore p equals 2 minus root 23. And that's it, guys. This is the end of the question. Okay, question 7. Show that the equation 8 tan theta equals 3 cos theta may be rewritten in the following quadratic sign form. Okay, so there's actually a very beautiful way to approach this, yeah? Now notice how all the result ends in a sine, but we got a cos and a tan. So our objective is to somehow convert this into some kind of sine equation. Well, thankfully, tan theta can do just that. if we say that, okay, let tan theta be re-represented as sine theta over cos theta, and this, by the way, guys, is one of the trig identities, we can now substitute that back into the equation. So let's put it over here, yeah? So part A, we now have 8 sine theta over cos theta, and this is equal to 3 cos theta. Now it's always preferable, guys, if we clear the fraction, yeah? So if we multiply cos theta across, and if we do that, we will be left with 8 sine theta on the left equals 3 cos squared theta. Now another useful property here is the fact that sine squared theta plus cos squared theta equals 1. So this is actually the second trig identity that's worth learning. Now what's useful about this is the fact that we could rearrange a cos squared theta term and make it into a sine squared theta term. That is, if we subtract sine theta across, we'll be left with cos squared theta equals 1 minus sine squared theta. And that's exactly what we want now, because if we pop this back into here, we literally have an equation in terms of sine. So now, moving down a bit, we can say, okay, we're left with 8 sine theta equals 3 times now 1 minus sine squared theta. And if we just expand this, we got 8 sine theta on the left. On the right, we got 3 minus 3 times sine squared theta. And just looking at the original expression, well, we can literally get that because we got all the terms. We just move everything to the left-hand side, so plus 3 sine squared and minus 3. You should get the expression of 3 sine squared theta plus 8 sine theta minus 3 equals 0, just like they want. Now for the second bit, it says hence, so once again, use your previous results. Solve for x between 0 and 90 degrees, the equation 8 tan 2x equals 3 cos 2x, giving your answer to 2 decimal places. So notice how this equation is actually similar to the first equation. The only difference is that theta has been replaced by 2x. So we could actually use the rewritten form, which is actually more useful because it's easier to solve, and replace theta with 2x. So let's begin from here, yeah? Let's start from part B. So let's say, okay, we now have 3 sine squared and then 2x instead of theta plus 8 sine 2x minus 3 equals 0. Now to solve this is actually a quadratic equation. We could just pretend instead of sine 2x we have y's, yeah? So we could say let y equals sine 2x. So we actually have 3y squared plus 8y minus 3 equals 0. Now this is a lot easier to solve, guys. This is way easier. So I would just use a quadratic formula because it's quick and easy. So using the quadratic formula, we can say let y equal minus b plus minus square root of b squared minus 4ac over 2a, where our values of a is the coefficient of y squared, which is 3, b is the coefficient of y, which is 8, and c is the constant term, minus 3. So guys, just replace all the letters with the true values, and once you do that, you should get y values of a third or y equals minus 3. And these are actually the same as, now if we just replace y with sine 2x, yeah, these are actually the same as, so therefore sine 2x equals either a third or sine 2x equals negative 3. So sine inversing the first result and making sure your calculator is set in degrees mode, you should get a 2x result of 19.47 degrees. However, if you sine inverse this one, you would actually get a math error. And the reason behind this is because you can only sine inverse values between -1 to +1. So technically, -3 is outside the range. That's why it doesn't make sense. So at this stage now, we go back to our interval and we ask ourselves what kind of x values do we need. We need answers between 0 and 90, yeah? Now we have one set of answer. I mean, we could actually get the result, but my advice, guys, never divide by 2 yet. The reason being is because you need to firstly find all the sine results, yeah? Now to get additional sine results, I recommend using the cast diagram, yeah, which is CAST. Because we're using sine, we're interested in the S part. And we always use the A because A means all, and it's always for positive results like we just got. So to use this properly, what I do is we always label 19.47 in both of these quadrants. So put an angle here, and it's always towards the x-axis, yeah? And so this is going to be worth 19.47 degrees, and this angle's width is also 19.47 degrees. And the way we actually compute this is that we actually start from the right hand side, so this is actually a zero margin, and we go all the way around until we hit the next one here. So what this means is that we traveled an angle of approximately 180 less than 19.47. So actually that's the other result. Other result would be 180 minus 19.47 degrees. But this is for 2x, right? And of course the first result is just from 0 to 19.47, which we have. Now that means to get the actual value of x, we just got to half both these answers. So we say, okay, therefore x is going to be 19.47 over 2, or x is going to equal the other one, 180 minus 19.47 over 2, and this should give us 9.74 degrees, or 80.26 degrees. And that's it, guys. So an arithmetic series has first term a and common difference d. Prove that the sum to n terms of the series is this formula here. Okay, so to prove the sum of any arithmetic series, we firstly got to start with how the sum actually looks like. So the way I do this, guys, yeah, I'll firstly try and define how I'd work out the sum firstly, yeah. Well, we always begin with the first term a, yeah. So suppose you got first term a, and then you need to add up the second term, right? Well, the second term is calculated after you added a common difference d. So we can say that the second term is a plus the extra difference d. Well, this is the first two terms. How about third term? Well, it's going to be, of course, this result here, which is a plus d, and then you're going to add another d, so it's going to be a plus 2d. So once we keep on adding loads and loads of results, if we want to add up all the way to, let's say, n terms, yeah? So this is basically Sn. We're going to keep on adding until we get to a plus n minus 1d, yeah? Because if you think about, this is the first term u1, this is the second term u2, third term u3, n minus 1d has to be un. So this is all good, guys, but however, this one equation is not enough to actually prove the sum. And the reason why is because we need a second equation. Now, another equation we could write is actually the same equation, ironically. But the only difference is, instead of writing it upwards in ascending order, we're going to write it in descending order, starting from un, yeah? So this would be un plus un minus 1 plus dot dot dot, and we're going to go all the way down to u3 plus u2 plus u1. So let's go ahead and add this result to this result, yeah? What we're actually going to have here is Sn plus Sn is 2 lots of Sn's. Well, a plus un, and we know what un is a plus n minus 1d. We're going to have 2 a's, because it's 2a plus n minus 1d. And then if we just go straight to the last one for convenience sake, so just write plus dot 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 plus. If we do un plus u1 again, that's going to be another 2a plus n minus 1d. And well, if we did any other term in the middle, we'll also get 2a plus n minus 1d. Now the question is, how many of these do we actually have? Well, technically, if we look at it this way, we had the first term and went all the way to the mth term. We actually have n lots of these, yeah? So there's actually n lots of 2a plus n minus 1d's. So that means we now have n lots of 2a plus n minus 1d. And that all equals 2Sn. So conveniently, divide this by 2, you're now going to get n over 2 times 2a plus n minus 1d. And that's the proof done. And now for part 2, it says that sequence u1, u2, u3 dot 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 is given by this expression here. Find the value of u5. Well, to use this formula, it just means that when n equals 5, so just plug in n when it's 5, you just get u5. So u5 is just literally 5 times 5 plus 3 times minus 1 to the power of 5. And then put this in the calculator, you should get 22. Now also find the value of the sum, so this sigma means a summation, yeah, from u1 all the way up to u59. So in general, all that really means, guys, is that we need to find the sum of u1 plus u2 plus dot 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 all the way up to u59. So to work out the sum of this, let's go ahead and plug in 1, then 2, and 3 and see what happens, yeah? So, okay, so let's go ahead and find u1 first, yeah? And guys, I recommend you don't do this with a calculator for now. So put in u1, so replacing n of 1, we're going to get 5 for the first one, And for the second bit, you got 3 times minus 1 to the power 1. Well, minus 1 to the power 1 is minus 1. So minus 1 times 3 is minus 3. Okay, let's just leave it like that for a second. For U2, plug in n equals 2, you're going to have 10. And then plug in 2 here, this becomes square, so you get just 3 times 1, which is plus 3. And now for U3, you're going to get 15, and this time, minus 3. So actually, you can see it kind of like alternates. So U4 is going to give us 20 plus 3. And if we keep on doing this, we can see that for odd terms, so for like U1 or U3, you get negative 3. For even terms, you get positive 3. So this implies that at U59, well, what do we have? We're going to have 5 times 59. That's going to give us 295. And because it's an odd term, minus 3. So what I would personally do, guys, is I would partition this list here. I'll add up all these terms that's going up in 5s. And then I'll add up these terms separately that's alternating between minus and plus 3s, yeah? So we can say that the sum of the first 59 terms would be the natural order, which is 5 plus 10 plus 15 plus ... which is all going up in 5s, by the way. And then plus, and then looking at the other list, we've got minus 3 plus 3 minus 3. So you're going to have minus 3 plus 3, minus 3 plus 3 plus ... and it ends in minus 3. Now, if you notice this carefully, for every 2 terms, they cancel out. Minus 3 plus 3 is 0. So every 2 pairs. So if we look at it, we have U1 and 2, U3 and 4. So by the time they get to an even term, they cancel out. So when you get back to an odd, you're left with minus 3. So that means all of this actually just results to minus 3. Now for the top half, this is just an arithmetic series, guys, yeah? You got first term A, which is 5. You have a common difference of 5. And you actually have 59 terms. So we can use the summation formula, which is used in, over here. We can use this formula up here. So we can say, therefore, the sum of all of this is going to be n over 2, so 59 over 2, big bracket, 2 times a, plus n minus 1, which is 59 minus 1, times the common difference d, which is 5, and then wherever that is, we're then going to subtract it by 3, okay? And finally, when you do all this, guys, if you put all of this in your calculator, just drop it all at once, you should get a result of 8,847. And this question is done. Okay, part A. Sketch the curve of equation y equals 3 times 4 to the x, showing the coordinates of any points of intersection with the coordinate axes. Okay, so guys, this is literally your exponential or power graph. Now, exponential power graphs always take this form. It's always y equals a times b to the x, yeah? And the typical shape is always the same. There's literally no difference. You always got your x-axis like this, and you have a y-axis, and the curve looks a bit like this, shooting upwards and never touching the x-axis, yeah? And as for the y-intercept, it always hits at the point A, so wherever the constant is in front of the bx. In our case, it's 3, yeah? So actually, this graph is the same thing, but instead hits at 3. And that's it, guys. This is literally all you have to do. Now for part B, it says that the curve of equation y equals 6 to the 1 minus x meets the curve of equation 3 times 4 to the x, so basically the same one, at the point P. And they want us to show that the x coordinate of P is given by this log expression right here. Okay, so when two curves meet, that literally means to equate these together, yeah? So essentially we have this, guys. We have 3 times 4 to the x, which must equal 6 to the 1 minus x, okay? And to resolve this, guys, you can just take logs on both sides, and that's personally the easiest way to do it. So taking logs on both sides, you can have log 3 times 4 to the x equals log 6 to the 1 minus x. Now, some of the properties of logs is that if you're multiplying inside, it's like adding 2 separate logs. So we're going to have log 3 plus log 4 to the x. And then when you've got powers involved, and when you've got powers in the log expression, these go in front of the log. So the 1 minus x goes here, so 1 minus x times log 6. And again, repeating on the left side, guys, you got log 3. The log 4 to the x becomes plus x times log 4. And we could just expand the right hand side, yeah? Open the bracket. So you got 1 times log 6 is log 6 minus x times log 6. Okay, so I think we're almost done. Now all you want to do is literally move the x terms to the left and the non-x terms to the right. So I'm going to plus x log 6 across and subtract log 3. So this means you're going to get x log 6 plus x log 4. And on the right, you now have log 6 minus log 3. Okay. So on the left hand side, we can now isolate the x by factorizing it out here. And inside the bracket, you're going to have log 6 plus log 4 is now going to equal log 6 minus log 3. And finally, one more step, you can now just divide this bracket across here. And you're going to be given x equals log 6 minus log 3 all over log 6 plus log 4. Now this is actually the answer, but they want it in a particular form, right? And it does look kind of different. Now what you can do is still apply more log properties. Two of the properties are here. If you're subtracting two logs, it's like dividing the terms. So it's like saying 6 divided by 3. This is going to give us a log 2, okay? Because 6 divided by 3 is 2. For the bottom, when you're adding logs, you multiply the terms. So it'll be 6 times 4, which is 24. So you're given log 24 on the bottom. And now notice how they have little base 10s as well. Thankfully in logs, you can literally stick in the same base up and down. So this is the same as log 10 2 over log base 10 24. And by the way guys, a regular log is the same as log to the base 10. So these are actually identical expressions. But yeah guys, this is it for question 9. And finally guys, number 10. So a curve C has equation y equals 4x cubed minus 9x plus k over x for positive values of x, where k is a constant. Now the point P with x equaling a half lies on C. Given that P is a stationary point of C, show that k is negative 3 over 2. Alright, when you have stationary points, this literally means that you want to differentiate and set dy over dx over 0. Because stationary points are essentially turning points with flat gradients, yeah, where dy dx is 0. So flat gradients means dy dx is 0. Now before we differentiate this, it's very important that you put all of this into indice form. So all the x's must have powers. You can't have fractions. So what I would do guys, is I would rewrite this y equation and keep the first two terms, keep 4x cubed minus 9x, but then change k over x. So if you got x to the bottom, to bring it to the top line, it becomes x to the negative 1. So it becomes plus k x to the minus 1. So this is the reciprocal indice here. Now we want to go ahead and differentiate this. So I'm going to try and bring it down a bit. So to differentiate that, so this is part A. Let's write dy over dx. The rule to differentiate is that you just have to drop the power. So it'll be 3 times 4, which is 12. And then subtract the power by 1. 3 take away 1 is 2. For the next part, if you're left with just an x, that vanishes, so you get minus just 9. And again, for this one, you drop the power down, so it'll be minus 1 times k, which is minus k x, and subtract the power by 1. Minus 1 take away 1 is minus 2. Okay, so this is good. And if you remember, because it's a stationary point at the point x equals a half, we're going to set dy dx to 0, yeah? So we say, okay, when x is a half, dy over dx is 0. So now, just doing both of them, this means we got 12 times a half to the power 2 minus 9 minus k times a half to the negative 2, and it's all supposed to equal 0. So all you got to do now is just tidy all of this up. So I would put the first two terms in the calculator, and doing so, you're going to get a minus 6. And if you write a half to the power minus 2 in the calculator, you're just going to get a 4. So this would be minus 4 times k. And that all equals 0. Now this is straightforward. You just have to make k the subject to get minus 3 over 2. So just rearranging this, you can see that k is now going to equal 6 over minus 4, which is actually minus 3 over 2. And that's A done. Now for part B, we need to determine the nature of that stationary point at P. In other words, we need to find the second derivative and check if it's greater or less than 0 at x equals a half, yeah? So let's do that right now, guys. Let's get the second derivative. Now for part B, we can say second derivative is d2y over dx squared. So differentiating this expression, 12x squared becomes 24x because you just drop the 2 down. 9 disappears because it's a constant. And then minus kx to the minus 2. Well, all you do is drop minus 2 down, so it becomes plus 2k. And then subtract the power by 1, you get minus 3. Now we know what the value k is, don't we? It's actually minus 3 over 2. So we can say, okay, this is the same as 24x. And so 2 times minus 3 over 2 is actually minus 3x to the negative 3. Now, to determine the nature of a stationary point at P, we just plug in the x coordinate at P, which is a half. So next we say, okay, at P, when x is a half, we have d2y over dx squared equals 24 times a half minus 3 times a half to the negative 3. Literally put that in your calculator, guys, and you get a negative result of minus 12. And this is less than 0, so this is actually a maximum point. So x equals half is a maximum. And that's literally it for part B. And finally, for part C, we are told that the curve C actually has a second stationary point. Now, using algebra, find the x-coordinate of this second stationary point. So, stationary points can actually be found when you have a dy dx equation and you set it to 0 and you solve for x. Now, because it's telling us that there's two stationary points, this is probably telling us that the dy dx equation is actually a quadratic equation. Because two stationary points, well, usually that's what it would imply. So guys, I've already gone ahead and copied out the dy dx equation here, and I've replaced the k with minus 3 over 2, so it looks a bit like that. And because we're going to start from here and set it to 0, this is where we're going to try and solve. So to solve an equation like this, it's probably better we get rid of any negative powers, yeah? So I would probably times everything by x squared, so this part cancels out, yeah? If you do that, we're actually going to get 12x to the power of 4, and then minus 9x squared, and now we're just left with 3 over 2, and this is equal to 0. So actually, guys, if we look at this carefully, this is secretly a quadratic in disguise. And if you want to make it easy for yourself, you can say something like, let, I don't know, z this time equal x squared. And if you do that, you'll actually have something like 12z squared minus 9z plus 3 over 2 equals 0. And yeah, this can easily be solved using a quadratic formula. So just using a quadratic formula, guys, it's going to be something like z equals minus b plus minus the square root of b squared minus 4ac all over 2a, where in this case a is 12, b is minus 9, and c is 3 over 2. But I'm just going to write that as 1.5, yeah? And if you put this, you're going to get two z results. The first one is going to be a quarter, and the second is going to be a half. Okay? And since we know that z equals x squared, so we can just update this saying x squared equals a quarter or x squared equals a half. To find x, you're just going to square root both of them, yeah? Square root both sides, you're going to get a half here. And square root this one, you're going to get root 2 over 2. And because we know that the first stationary point was a half, which was actually this one, this means this is the answer here. So the final answer would be x equals root 2 over 2. And that's it, guys.
I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go into my channel page, hit the subscribe button and hit the bell for more notifications. And if you want, you can do personalized or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.